I would like to welcome everyone to the product release webinar for the newest version of the VX toolset for ARM. My name is Roger Smith. I am responsible for technical marketing at Tasking and will be the moderator for today's webinar. As a recognized leader in high quality, functionally safe, and security compliant embedded software development tools, Tasking allows you to create best-in-class code size and performance with compilers, debuggers, and RTOS support for industry-leading microprocessors and microcontrollers. In addition to the VX toolset for Tri-Core, Tasking offers toolsets for the Infineon Travio 2 and NXP S32K, S32E, and S32Z multi-core microcontrollers based on the ARM Cortex-M and Cortex-R architectures. The Tri-Core and ARM toolchains are ASPICE Level 2 compliant, conform to the ISO 21434 cybersecurity standard, and are TÜV certified according to ISO 26262 up to ASIL D. With the acquisition of iSystem, Tasking now offers a full system solution as the blue box establishes the debug and trace connection to the target processor, and WinIDEA provides a versatile and powerful embedded software IDE. The Tasking safety and security ecosystem includes the Tri-Core Inspector, which provides embedded system developers a method for identifying if any SIL toolset related issues are in their compiled output code. The Safety Checker static analysis tool helps to ensure freedom from interference is maintained in ECUs with software components having different ASIL levels. The qualified C libraries for Tri-Core were developed as a safety element out of context, using state-of-the-art algorithms resulting in reduced memory footprints, reduced execution times, high numerical accuracy, and about 200 functions qualified for ASIL D use. The Tasking performance tools, Embedded Profiler and Multi-Core Performance Tool, provide fast and efficient access to flow tracing information to resolve stalls, cache misses, and optimize the core load in your multi-core system. Finally, Tasking offers RX optimized LAPACK performance libraries to provide accurate solutions for your complex mathematical operations, and the Tasking Pin Mapper tool provides hardware configuration and RX port mapping for your PCB development. Our webinar today will focus on the newest version of the Tasking VX toolset for ARM, which now supports the Cortex R52. This webinar will be recorded and available on our website at the link shown below. In case any questions arise during the webinar, we invite you to use the Q&A function on your Zoom console. All questions will be answered at the completion of the webinar. I would now like to introduce our speaker for today's webinar. Muhammad Bilal Afzal is a software engineer with over 10 years of industry experience in designing, implementing, and debugging automotive subsystems. In his previous roles, he was involved in the qualification of the C library in context of ISO 26262 and development of infotainment system functionality. As the technical marketing manager for Tasking, Bilal supports a wide range of multi-core embedded software development tools.
Thanks very much, Roger, for the introduction. Before we begin, I would like to wish our attendees good morning, good afternoon, or good evening, depending on what part of the world you are tuning in from. As of now, automotive electronics has evolved into a network of interconnected ECUs, performing advanced algorithms relying on multi-core microcontrollers, data sharing, multi-threaded operations, and high-speed communication. These advancements have led to the most basic functions having an automotive safety integrity level rating. Moreover, with the ever-increasing ADAS functionality, with higher ASIL requirements, needs qualified tools and defined processes. Tasking is a one-stop solution for safety-critical multi-core development tools. Let's start with a scenario. let's suppose that our two engineers have been tasked with designing, say, Cortex-52 safety application, which is based on S32E 2270. This can be a difficult task, maybe like climbing to the peak of the Mount Everest. As our two engineers begin their journey to the summit, they will encounter several challenges along the way. The first natural step is of the process involves the selection of the appropriate microcontroller, like NXP S32Z. This device has multiple ARM Cortex R52 cores. It also contains hardware security engine, which is based on Cortex M7. It has 5-volt analog and digital input-output with complex timers and a safety concept, thus making it ideal for automotive safety applications. The next step is to identify a toolset which supports both Cortex R52 and Cortex M7 cores, which are integrated into the device. Moving forward, we need automotive safety applications require ISO 26262 and ISO 21434 compliance for both hardware and the software. Then we also need a flexible and high-performing hardware debugger to fulfill our hardware debugging needs. And in the end, we also need a versatile and easy-to-use debug IDE, which can provide us trace and signal monitoring capability. And then we can reach to our summit. From the task during this webinar, Tasking will offer an ARM toolset to help our two engineers during their development of a functionally safe, security-compliant automotive safety system using the NXP S32E. Moving forward, you can see a flow chart where starting from the source code and ending running on the hardware, we have different steps. And then we also have different products from our portfolio, which fulfills several goals and provide different benefits. Starting on the source code level, we have the safety checker, which provides freedom from interference when there are multiple software components with different AC level running on the same core of the microcontroller. Now comes to the compilation part, where there we have our VX toolset for ARM version 7.0r1, which is our latest version for ARM toolchain, and it provides us optimized code generation. Then we have a plugin which takes us from the compiler perspective to the debug perspective, and there we have our versatile Win IDEA IDE, and with the help of our latest generation of Blue Box, we can directly communicate to the target. Inside Win IDEA IDE, we can flash, we can debug, we can gather traces and do the analysis on them, and we can do also different type of testing like unit, system, and regression testing. Now, this block diagram is showing us different components or the architecture of different devices we are supporting. We will keep supporting S32 microcontroller. And now with our latest update, version 7.0, it has support included for S32E and Z real-time processors, which are based on Cortex R52. For system manager part, which is based on Cortex M33, we have our next planned release, which will come out in the Q3 of 2024 current year, and then we will also provide support for Cortex M33. Moving forward, this is a table showing different characteristics of the different devices we are supporting from NXP. and you can see different features. And I think the most important one are the cores we are supporting and number of the cores. You can see that with the K devices, we are supporting all these cores, and with the addition of E and Z, which has 8 Cortex R52 cores, we are supporting those, and also Cortex M core. Apart from that, you can also see different other features like communication protocol or the security mechanism of these devices. We will keep supporting Infineon Travio 2 devices. There you can also see in this table that the different cores which we are supporting and of different devices. And in the context of CM0 plus, which is a secondary CPU for HSM, it is fully AVETA compliant and can also be used for non-security tasks. Now come to the overview of the different features of our latest generation of VX toolset for ARM version 7.0r1. It was already released end of the last year, say in December 2023. The feature set will keep support. The feature set included the following points. We will keep supporting ARM v6m, ARM v7m, ARM v7e instruction set, and we also added the support of ARM v8r and ARM v8m architecture. We will keep supporting S32K series, and now we also included S32E and Z devices with the corresponding Cortex R and Cortex R52 based architecture. On the hardware debugger support side, we have Eclipse IDE, which now directly connects with the blue box, and you can directly communicate with the board. And on the software debugger side, you can always use onboard GDB server support, or you can also use virtual ECU. It is a really trendy topic, and we believe that industry is moving towards that path, because virtual ECU provides quite many advantages, and we can test various scenarios in a simulated environment. It is not only cost effective, it also evaluates the software functionality and interaction with the environment and component models long before any hardware is involved. Last not least, we also developed a Eclipse plugin, which allows you to launch our versatile Win Idea IDE from Eclipse IDE itself. Moving to the compiler side of our ARM latest ARM release version 7.0, we have an integrated embedded development environment, which is based on 64-bit Eclipse IDE, which supported both C and C++. And it provides the same experience as with our VX toolset for RX. With our highly configurable linker and LSL language, you can always have optimal memory control, and you can use it to do quite many different tasks. We extended the support of, we introduced this, the support of ISO C18 language standard. And on the C++ front, we added C++ 11, 14, 17, and partially C++ 20 support. This toolchain only is being supported with Windows and Linux 64-bit versions. And we also conforms to the leading industry standards such as MISRA, CERT, and other leading standards. Coming to this toolset feature, this table is showing us or summarizing all the different points. With respect to the features, we already discussed some of them, but I think the most important one is about our technology. Our technology is a proprietary technology, and it is not based on any open source technology. This means that we have full control on it, and we can provide the most optimized code for any specific device which we are supporting. Apart from that, we have this highly configurable linker with versatile scripting language which provides you flexible memory control. We have this integrated WinIDEA debug IDE, which you can launch from the Eclipse itself with the use of plugin. We have a full support of our tasking, next generation tasking Blue Box IC7 Mini. Regarding the backward compatibility, we are providing full support for all the previous toolset versions. If you have compiled or you created some project with that, you can just link it with our latest toolchain and you can use it. It has an integrated static code analysis for MISRA and CERT. And it also supports ARM instruction set simulator and simulator debugger. Last not least, we also provided software examples that are based on Travio 2 STL and NXP S32DS so that you can just get started easily. Coming on the safety side, if we talk about the safety features, we developed our toolchain with the automotive SPICE level 2 processes. We have combined our safety and security manual into one manual, and we are providing qualified runtime libraries according to ISO 26262 up to highest ASIL level, ASIL D. We already have our TÜV certification for the last toolchain version available. And for this one, the latest release 7.0, we are in the process of getting certification. We are waiting, and it will be hopefully available in Q2 of 2024. This will also comprise of cyber security conforms according to ISO 21434. And the most important thing is that there is no additional qualification kit requirement because safety and the security manual will be the part of the product itself. Now, coming to this screenshot has been taken from our latest version of ARM toolset. You can see it looks very familiar because it is based on industry standard Eclipse IDE. There you can see the development perspective showing different windows. And on the right side, you can see our next generation Blue Box IC7 Mini connected with the board using an adapter. This is a screenshot taken from the debug configuration view. There you can see that you can add different profiles depending upon which hardware you want to use or you want to select. There you can see the older generation of the Blue Box enlisted, the new one also. One thing which you should keep in mind is that you need to configure and provide the required parameters so that you can communicate with the hardware in a correct way. Moving forward, this is the debug perspective of the Eclipse IDE. There you can also see different windows showing different information like disassembly, different registers, the value stored in these registers, the breakpoint, and the console. This screenshot has been taken from our WinIDEA IDE. There you will also get the debug perspective. The good thing about the flexibility of our tool is that it provides the option for both Eclipse-based debugger perspective and about WinIDEA IDE perspective. So whichever you are familiar with, you can use that one. There is an option available for both of them. Now coming to the licensing part, we have 3 different types of the license available, starting with the evaluation license. It has a time duration of 30 days. It is free of cost and it comes only in node lock mode. We have this evaluation license so that you can get it free, you can play around with it, you can see that how powerful our tool is, and you can gauge the performance of our tool, and then you can decide for either time-based license or perpetual license. Our time-based license can be either purchased for 6 months or for 1 year. The good thing is that the maintenance fee is already included in the time-based license, and it can either be purchased in node lock mode or the floating mode. And the last one is about perpetual license type, which is one-time buy-off. The first year maintenance is already included in the perpetual license, but for the next year, you need to buy a maintenance package so that you can keep getting the updates. It also comes in 2 different modes, node locked and floating. Now coming to different editions, we have this standard edition, which will keep supporting Cortex-M cores like M0+, M3, M4, and M7. It can have a geographical scope of single site, country, or continental. And then we introduce another edition, which is called Professional Edition. It will have support of both Cortex-M and Cortex-R. It will also have the same geographical scope. It could either be single site, country, or continental, and the license type could be, again, node lock, floating. I just want to make one point here that we have a separate license for contest integration. I would advise to contact our sales account manager for further information. You can directly contact our account manager, or you can always use contact form on our official website. We introduce some bundles. The first bundle is Performance Basic, which includes WinIDEA Standard and IC7 Mini. And the second one is Performance Debug, which includes WinIDEA Pro and IC7 Mini. IC7 Mini is the first device of our next generation hardware debugger. But during this year, we will also launch IC7 Pro and IC7 Max. And then you will also have the availability of Performance Debug Trace and Performance Debug Trace Sync. Now coming to different probes and adapters, we have 2 different types of probes, active probe and passive probe. Passive probe have limited debug and trace support. The adapters of the last generation of the passive probe are different for the newest generation. And when it comes about to talk about the active probe, it has maximum debug frequency supported, and also it can provide high-end trace interface up to 4 HSSTP lanes, and it can run separate traces in parallel. Our newest active probe is not supported on S32K3, which is HSSTP2. So now let's look at the key takeaways. VX-toolset for ARM version 7.0r1 has support for Cortex-M, Cortex-R from Infineon, NXP, and other semiconductor providers. Support for tasking Blue Box has been added with the Eclipse plugin to launch WinIDEA IDE. We added the support for ISO C18 standard, and on C++, we have full support for 11, 14, 17, and partially C++ 20. We conforms with MISRA C, CERT C, and other industry-leading standards. It provides the same experience as VX-toolset for TriCore. And development of higher ASIL level software can be fulfilled with proof-certified toolset for ISO 26262, ASIL D, and IEC 61542 SIL level 3. In the last, I just want to emphasize on the tasking is a one-stop shop for embedded software development, and we provide end-to-end solution for all different needs of safety-critical applications.
Well, thank you, Bilal, for the awesome update on Tasking's newest toolset for ARM. We would like to invite our webinar attendees to participate in the product release webinar for the VX toolset for ARM 7.0 R2 later this year. During that time, we will be introducing our toolset for the Cortex M33. Registration emails will be sent out approximately 2 weeks prior to the event, and we also offer you to visit the Tasking webpage where you can get information on all of our future events. If you are interested in a quote, or if you would like to get an evaluation license or learn anything else about our Tasking toolset for ARM, we invite you to visit the link here shown on the screen. If you need any additional information, if you're looking for how to find your sales contact, we've also provided you here some additional links here that you can use. So with that, it brings us to the Q&A session of our webinar. So let's look here into the question grab bag here. Okay, so we have received a couple of questions. The first question is, I'm currently a user of version 6.0 R1 of the toolset. Is it possible for me, or how do I upgrade to the latest version of the toolset?
Thanks, Roger. Yes, the customers with a valid maintenance can upgrade to the standard edition of VX toolset for ARM version 7.0 R1 free of cost. But for newly introduced professional edition, customers must pay an upgrade fee for the new device support.
Okay, thank you, Bilal. Here's a question again. I believe I heard something regarding M33 core support. Could you please repeat?
Yeah, so basically, it is in our roadmap. M33 will be supported in next planned VX toolset for ARM version 7.2 R2, and the target is Q3 of the current year 2024.
Okay, thank you. What is the plan for VX toolset for ARM 7.0 R1 safety certification, and is the compiler already qualified?
The VX toolset for ARM product contains the tool qualification, aka safety and security manual, which enables you to use it in any ASIL-B to ASIL-D projects. The tool certification is done by an independent company during an audit. The certification is planned for the completion in the mid of 2024, and the safety and the security manual will be the part of the product.
All right, and we have one last question here is, can you please once again review the hardware debugger options for the VX toolset for ARM?
Yes, basically there are two different options. The one is included with the VX toolset for ARM, which is the ability to connect with the GDB server. And the other one is the Eclipse plugin connects to the WinIDEA IDE and can use tasking blue box.
All right. Well, thank you very much again, Bilal, for your awesome webinar. And this concludes our product release webinar for the VX toolset for ARM. We would like to thank you for your participation and wish you a great rest of your day.
Thanks, everyone.